All right, guys, so we're going to take some time to go over these review questions for the quiz that you're going to be taking tomorrow. So this is the Chapter 9 Quiz 1 review. I would highly encourage you to go ahead and try these problems on your own first, and then check them with the video. So you might want to try to do the first one, then pause and watch again. If you don't think you're going to have enough time to do that, then go ahead and walk through each step with me. That's fine by me. But just make sure that you review this for the test that we're going to be, or the quiz that we're going to be taking. All right, so this first one, it asks us to graph the function. So if I were you, what I would do is I'd go ahead and I'd get out my graphing calculator, right? Remember that we're going to go to the y equals button, clear everything out to graph it. Now remember, when you're doing this one, right, you're going to go to math in order to insert. So I'm going to go to math to insert my absolute values. We scroll over to number, press enter, right? Oops, I forgot to put my 3 first. So I'm going to clear that out, press 3, go back to the math function, go over and get in my absolute values again, right? So now my x plus 4 has to go inside of my absolute values, and I scroll out to put the minus 2. Now remember, we like to graph it first to get an overall general view of this, but in the end, I really need to create a table of values for myself to graph from. And the key value that I need is this vertex point, this middle point right here. And for me, when I look at that, that looks like the x is about 1, 2, 3, at about 4. So when I go to my table, I can go ahead and scroll to 4 and see what is happening there. Oh, it wasn't 4, right? It was on the left side, so it was actually negative 4. So I need to go over to negative 4. And when I look, yep, I have a 2, and then it starts duplicating on either side. So I know that negative 4 for my x value was my center point, and negative 2 went with that. And then I can go above and below for a couple of points. So negative 5, negative 6, negative 3, and negative 2. And then I can put the 1s with each of these and the 4s with each of these for my y values, move my graphing calculator out of the way, and then go ahead and plot my points. So x is negative 6, y is 4, x is negative 5, y is 1, negative 4, negative 2, negative 3, 1, and negative 2, 4. And then I'm going to go ahead and grab my straight edge, because you know that you need to make it a straight line. If it's wavy, I take off points. And remember to put your arrows at the end to show that it continues on. Now, I also need you to state your domain and range for these. So in case you don't remember, let's state our domain and range, remembering that domains are the x values, right, which is the left and right. So I need to ask myself, do I ever stop going to the left? And I don't, so that's negative infinity. Do I ever stop going right? No, so that's positive infinity. So my domain is negative infinity to positive infinity. For my range, that's my y values, right? So that's my up and down. So I need to ask myself, do I ever stop going up, or do I ever stop going down? And the answer is, I never stop going up, so that's positive infinity. I do stop going down right here. And remember, we're looking at the y values in this case, right? I'm looking at my y values. So I want to know the y value at that point, which is negative 2. So negative 2 is that end of it. So then when I go ahead to do this, right, my lowest value is negative 2, and it gets a square bracket because that's a number that's actually included in the graph, and a positive infinity with the parentheses. Okay? So now we're going to go ahead and look at our piecewise functions as well. And remember, when we're looking at our piecewise functions, like we are in number 2, what we're really going to do is break it up into 2 different pieces. Right? So my first piece here is saying that the f of x is equal to x minus 2 for x greater than 2. So really, that's a fancy way of saying y equals x minus 2 for x less than or equal to 2. So I know that when I do my xy table, that 2 has to be the first number I'm going to use for my x. Even if it weren't an equal sign, I still have to find the 2 for that one, because it's still a point I will graph. And then it says less than 2, so I'm going to pick numbers smaller, like 1, 0, negative 1. So then I can go ahead and go to my graphing calculator like we did before, right? Go to our y equals button, clear it out, and now we're going to do the absolute value. So we're going to go back into that absolute value, which is the math button. X minus 2. I can graph it, but to be honest, I'm only going to take part of this graph, so I don't even really need to look at that as much as I need to look at the table and then pick the numbers that I need it to match. So at 2, x is 0. At 1, y is 1. At 0, x is 2. At negative 1, y is 3. And then these would keep going in that direction. So then I can go to my graph and plot my point. Now remember, I have to think about open versus closed circles. So since there's an equal to here, I know I'm going to make a closed circle at the 2 point. So at x is 2, y is 0, I'm going to make a closed circle. And then 1, 1, 0, 2, negative 1, 3. And I put the dots at the bottom to remind myself I'm going to keep going in that direction. So from this point, keep going in that direction with the arrow. Then I'm going to go ahead and do the second half of this graph, which comes from f of x is equal to x minus 2. So that's a fancy way of saying, it's a fancy way of saying y equals the square root of x minus 2. And then 4, x greater than 2. So just like before, I don't even care about the no or equal yet. That tells me that my first x value has to be 2. And then I can pick the numbers that are bigger than that, right? And it would keep going. And then I would have to go and find my y values. So I go back to my graphing calculator, I go to the y equals, clear it out, and type in the function, the square root of x minus 2. I can graph it to get a general look, so it's going to have to be a curved line. And then I can go ahead and go to my table. And even look, there's all those errors, right, which is telling me it's not possible there. The first point, which is the first point I wanted, was at 2, 0. So 2, 0. 3, 1, 4, and 1.4, 5, and 1.7. And I'm even going to put the 6, 2, because to be honest, I'd much rather just graph the whole numbers than the decimals. So now I can move my graphing calculator out of the way. 2, 0 would have an open circle, right, because there's no or equal. So I'm just going to put an open circle around it to show that that's open for this new one. Then x is 3, y is 1. X is 6, y is 2. And I could go ahead and put one of these in there, like 4 and 1.4. But then remember, my graph curves up, and we go ahead and put the arrow at the end. Remember, when you're looking at these graphs, right, if I were to draw a vertical line, I should only touch one of the graphs. The only time I would touch 2 is at that point 2 where both of them happen. Okay? All right, last one. For graphing anyways, that is. So we're going to be looking at this last one, which is going to work exactly the same way, right? We're going to go into our graphing calculator. We're going to create an XY table. Again, they're asking us for domain and range, okay? So we're going to have to go ahead, go to the y equals, clear it out, -4, math, absolute values, x plus 5, arrow out, -3, right? Go to the graph so I can get an idea of where this is happening, which looks like it's over here at like -1, 2, 3, 4, 5. So we go to our y, not our y equals, to our table and go to where it's -5 and see if the numbers on the x start repeating out. So -5, -3, and then we've got our 7s and our 11s. So yep, -5. -3 is my center point, it's my vertex, and then I take a couple of points above, so -6 and -7, which was -11 and -7, and then -5, -4, -3, which were also -7 and -11. Okay, so now I can go ahead and graph this, right? X is -7, y is -11 would be 1 off the graph, so I'll just make a little point slightly below, okay? And then we can go ahead and graph -6, -7, oops, and then -5, -3, -4, -7, -3, -11, and then again, because that was a straight line when I looked at my graph, I'm going to go ahead and get my straight edge to make the straight lines, arrows at the end. And then we have to do domain and range. Remembering that domain is my x, so that's my left and right. So does it ever stop going to the left? No, that's -infinity. It doesn't stop going to the right. So that's positive infinity. So my domain is negative infinity to positive infinity. Then I look at my range, which again means I'm looking at my y values up and down. It does stop going up right here, and I need to look at my y value there, which would be -3. And it never stops going down, so that's negative infinity. So my range is, my smallest number is negative infinity, my biggest number is -3, and because it's an actual number that's included in the graph, we put a square bracket. All right, so that's just a review of the graphs. Now let's review the function stuff that we were working on from before. So in this one, they're asking you to go ahead in number 4 and take these two functions and add them together. So really what I'm doing is I'm taking x cubed plus 2x squared plus 6, and I'm adding g of x to it, which is x minus 3. Now there's just those invisible ones out front, so that really doesn't change anything, right? Everything in there still stays the same when I distribute. And then I need to combine my like terms. So there's no other x cubed, so x cubed can just get brought down. There's not another x squared, so plus 2x squared gets brought down. There's not another x, so we just bring that one down. And notice, I'm bringing it down in order because you have to put it in order from highest exponent to lowest. And then I can go ahead and combine my like terms of -6 and, or positive 6 and -3 to get a positive 3. And I know I wasn't going to get a final single digit number in the end because it's asking me for x. If that was f plus g of 2, then I should get a number at the end. All right, so, sorry about that, guys. It'll brighten up in just a second. Okay, so if I'm looking at number 5, it's asking you to take this graph, y equals the square root of x, and translate it 9 units to the left, and then 5 units up. So we have to think about what makes it move left and right, what makes it move up and down. And so remember, to move to the left, you have to change what's inside. And remember, because it's inside, it would do the opposite of what you would normally think. So normally, I think of moving to the left as going in the negative direction, but since we're doing the opposite, we would put plus 9. Now remember, plus the 5 units up, this is what changes the outside, and the outside just stays the same as what you would normally think it is. So up would be plus 5. So then I can go ahead and I can take my base equation, y equals the square root of x, and now on the inside I'm going to add 9, and on the outside I'm going to add 5. And that's your final answer. Okay? All right, number 6. Now, number 6 is one that I want you guys to be really careful with, because a lot of you, when you take your quiz, are going to look at this and think that this is a multiplication symbol. But remember, this is a composite, right? It's a composition, which means I'm going to take the function g of x, and I'm going to put it in to the function f. So basically, when I'm looking at this here, I'm going to take all of this, my g of x, and I'm going to put it in place of the x in the other one. So I would have 2. Instead of x, it'll be 3x plus 6 over 2, and then plus 2. So to simplify this, right, there's really, what's happening between these is multiplication. And if I'm multiplying, I really want a fraction times a fraction. So this is really saying 2 times everything on the top, because we're multiplying the top, and 1 times 2 on the bottom would be 2 plus 2. And now the nice thing is 2 divided by 2 is just 1. 3x plus 6, right? So if I distribute the 1, it would stay the same, giving me 3x plus 6 plus 2, which is 3x plus 8 when you combine your like terms. So I know that f of g of x equals 3x plus 8. So make sure you're very careful, because if you would have multiplied, it'd be very different than this composite, which is really a fancy way of saying substitution, right? We're substituting one into the other one. All right, so now let's look over at number 7. look at number 7. It's different than the other ones that we've done because there is an actual number here. So since there's the number there, we're actually going to find each one of these and then subtract them from each other. So I'm going to find what is f of negative 3. I'm going to find out what is g of negative 3. And then because there's subtraction between them, we'll subtract once we find those values. So f of x is x squared minus 9. But now, instead of x, we're putting in negative 3 squared. Make sure you put it in parentheses, otherwise you'll forget to square the negative. So negative 3 squared would be negative 3 times negative 3, which is 9, and 9 minus 9 is 0. Then we're going to go ahead and do that same thing with g, but g of x is 3x minus 5. So that'd be 3 times negative 3 minus 5, and 3 times negative 3 is negative 9. Minus 9 is negative 18. Now be really careful with this next step because it's asking us to subtract them. So really I'm taking 0 and I'm subtracting not just 18 because all of the negative 18 was g of negative 3. So it's minus negative 18, right? And minus a negative really means adding a positive. So 18 is your final answer. If you would have forgotten to put the minus sign and the negative, you would have gotten negative 18 instead. So be very careful with that. Remember that the minus comes from the problem and the negative comes from having simplified g of negative 3. All right, now number 8, again, be careful with because this is not multiplication, right? It's not multiplication. Instead, it's a composite again, which means we're going to take g of 3 and plug it into f. So unlike the last problem, I don't want to find f of 3 and g of 3. I want to find out what g of 3 is so that I can put that into the f. So I'm going to start out with g of 3 first, which g is 2x plus 4, which means 2 times 3 plus 4, which is 6 plus 4, which is 10 in the end. So g of 3 is 10. Now I need to take this 10 and I need to put it into the f function because once we find this, we're substituting it into f. So I'm not finding f of 3, I'm finding f of 10 because once I found g of 3, that answer gets put into the f. So since g of 3 was 10, 10 is what gets put into the f. And my f is x squared plus 2x minus 3, which is 10 squared plus 2 times 10 minus 3, which is 100 plus 20 minus 3. Well, 100 plus 20 is 120, minus 3 would be 117 is my final answer. And again, because I had a number there, I knew my final answer should just be a number at the end. All right, last one. Number 9. This, again, is one of those translating ones where you're supposed to take this as your base graph and translate it 4 units to the right and then 3 units up. So remember, left and right is what you do to the inside, right? And since it's on the inside, we do the opposite of what the operation normally would be thought of, because normally I think of the right as being positive, so I'd want to put plus 4, but since we do the opposite, it would be a minus 4 on the inside. Then, when it says 3 units up and down is on the outside. And the outside does the same thing that you would normally think it does. So if I want to go 3 up, I would add 3. So now the problem is, when I look at this base equation, y equals x squared, it's really hard to know where the inside is and where the outside is. So you have to remember that the inside, the inside is what's being squared. So here, the x is what's being squared. So when I rewrite this, I need to put it in parentheses so that I can square more than just the x. So then on the inside, I would subtract 4, and on the outside, I would add 3. And then that's your final answer. One little friendly reminder before you go. If you need to flip the graph over the x-axis, and I probably shouldn't say flip, I should say reflect. If you want to reflect the graph over the x-axis, we'll just put reflect the graph, make the coefficient out front negative. What I mean by that is, if I had something like f of x equals the square root of x plus 2, to make this flip, we would then change it to negative radical x plus 2. Okay, so that's just a friendly reminder. Make sure tonight that you review domain and range, piecewise functions, and remember to memorize how things change on the graph. How do I make it move up and down? How do I make it move left and right? Your homework tonight will be handed out, so make sure you do that as well. Have a good day.